Hey everyone, so this is going to be a brief rundown of the idea behind my Science Expo and its design. So space travel is very difficult, I assume we all know that. To get stuff from the surface of Earth into orbit is usually a very costly process involving millions, if not billions of dollars, and the burning of hundreds, if not thousands of tons of fuel per second in hugely costly and fuel-consuming rockets, like those used by the US. So my idea for this year's Science Expo is to cut all this money and rocket fuel out of the equation and use the power of air, of the atmosphere, of air at sea level, because of the air, like the air at sea level is under pressure, 14 pounds per square inch approximately. So my innovation would allow us to use that power to get this into space a lot cheaper and a lot easier. So, simply, my design would be that here's the ground, right? It would be it's kind of a space elevator, you've all heard of those, extending approximately 25 kilometers up into space, almost to where the atmosphere is non-existent. And so it would be around 50 feet wide and made of something like carbon nanotubes, like a very strong material. And basically there'd be doors at both ends, a way of getting all the air out. You'd load it with whatever, a capsule containing a satellite or whatever. You'd open the bottom door, the air would rush in because air goes from an area of high pressure to low pressure. It would rush in, it would push the capsule up into space, out into orbit, without using any fuel, except possibly that of running whatever it takes to get all the air out. And so this is simply my innovation. Now, obviously, a 25-kilometer tall space elevator made of a material more science fiction than reality is somewhat beyond my capabilities as a grade 10 student. So I've kind of decided to build a fun, simple model that's well understood and used by many physics teachers to demonstrate the power of vacuum. So what I've done is I've got a 4-foot long PVC pipe. I've set it up with a wooden stand. I've attached it to a vacuum pump. Thank you to the science department. I put a ping pong ball inside, a table tennis ball, about 40 millimeters in diameter, packing tape on both ends, run the pump, get all the air out until this is a vacuum. Then you pop this side with a needle or a pen or a pair of scissors or whatever. The air, which is at pressure around us, rushes in, pushing the ball along and out the tube. And by the time it gets to here, it has enough speed and force to punch through this tape and exit the barrel. And I found that my balls left the barrel at an average of around 140 miles per hour, which is actually pretty fast. So there you go. That's my innovation and the model I've settled on to demonstrate it. Thank you.